probability that the interval contains the unknown parameter.
Population mean is an average of a group characteristic. The group could be a person, item, or thing. When you compute the confidence interval on the mean, you compute the mean of a sample in order to estimate the mean of the population. Clearly, if you already knew the population mean, there would be no need for confidence interval.
Of a confidence interval for the population mean depends upon three factors: the point estimate of the population. The level of confidence in a confidence interval is a probability that represents the percentage of intervals that will contain if a large number of repeated samples are obtained. The level of confidence is denoted the standard deviation of the sample mean.
A clothing company, say US Polo, makes a jeans of waist size 32 and 34. Now, since the jeans is manufactured and made by machines, there is a slight margin or error in the waist size. Now, you and your friend X bought a 32 waist size jeans. You come home and measure the waist size of the jeans individually by the correct weight. You find the waist size of your jeans as 31.8 and X jeans had a waist size of 32.8%. Now, why did the company put a tag of 32 on a 31.8 and a 32.4 jeans? This is because the company assures that any waist size of jeans between 31.8 with a probability of X% where X is usually 95 or 99. This is classified as a 95% or 99% CF. This is how it is used, but maybe you'll never come to use this sample in a daily life.
Solve the problem here. We're being asked to construct a 98% confidence interval based on a set of data. This is the formula we're going to use. It's x bar plus or minus the t-score, and I'll show you how to find that in a moment, multiplied by s, that's the standard deviation of the sample, divided by the square root of n. N is the number of items in our sample. First we need to know the sample mean, that's our x bar. If we add all of these up and then divide by 10, we get a mean of 71. And the standard deviation for the data, standard deviation for this particular sample is 18.172. So we've found our S and we found our X bar. Next we want to find this t-score. We need a couple of steps to find the t-score. The first is we need to find the degrees of freedom. Let's see, I'll just write t-score here. So to find the degrees of freedom, we subtract 1 from our sample size. We have 10 numbers in our sample. If I subtract 1, I get 9. The second step we need to find the t-score is we need to subtract the confidence level from 1. There's 98%, so if I subtract 0.98, then I want to divide this number by 2. That gives us the alpha level at 0.01. We need these two numbers to look up the t-score in the t-distribution table. So I'm looking for degrees of freedom of 9 and an alpha level of 0.01. Here's my alpha level, 0.01. And if I look down to 9 degrees of freedom, here's the degrees of freedom in this column, I get 2.821. So my t-score is 2.821. Now we have everything we need for the formula. I'm actually going to work this part of the formula here, this t times s divided by the square root of n. So I've got t times s square root of n. That gives me 2.821, that's my t-score, multiplied by s, 18.172, divided by the square root of 10. And I'm going to figure this out on a calculator. That comes out to 16.22075. Now the confidence interval tells us to take the mean and plus or minus this figure. So I'm going to take the mean 71 and I'm going to subtract 16.22075. And separately I'm also going to add 16.22075. So this is our plus or minus. And 71 minus 16.22075 is 54.77925. And if I add this number to 71, I get 87.22075